So as part of framework, so we have learned Selenium Grid concept in the last class. So how we can run our tests on a grid environment. So how can we create a standalone grid environment, and then we have executed test cases on the multiple browsers. So today we'll see how we can run on Docker. So before that, let us try to understand something about Docker. So what is Docker and how we can use it and how we can set up the Docker environment. And after that, we have to know some basic commands in Docker. So otherwise we cannot directly use Docker. We have to know some basic commands. And then we will set up the Docker environment for grid, and then we will try to execute the test cases on Docker. So this is a concept today we are going to cover. So listen very carefully. This is something new concept and very important and also very interesting topic. So what is Docker? So Docker is basically follow the containerization. Containerization is something different. So earlier, if you want to run our test cases in multiple browsers or multiple operating systems, so what we have done is we have created a physical machines. Initial days, we have a physical machines. Let's say this is one machine and I have multiple physical machines like this. And all the physical machines are connected in one single network. And with the IP addresses, all the machines are internally connected. So these are all physical machines. And the physical machines are very costly. So it is very difficult to set up all physical machines, that to temporary purpose, right? So we don't use all the machines on a long time, only for the testing cycle. So how many days or how many months are testing for allocation. So only that particular period of time we will use them. So physical machine concept is got failed. So we cannot install multiple physical machines in their environment. So instead of physical machines, the new concept came into virtual machines. So virtual machines means we don't have a physical machines. We have one single machine, one single machine. In the same machine, we will set up multiple VMs. Multiple virtual machines means this is whatever operating system we are running in the main system, which is called host operating system. And on top of it, virtually multiple systems will go and run. So these are also having multiple operating systems. So this is maybe Linux, and this is Unix, this is Windows, something like this. So these are all different virtual machines we created and run them on single host. Okay, so this is a concept we have followed. This is called virtualization. Means whenever we want this VM, we can start it, and whenever we have done the work, we can stop that VM. And the VM, we can play this VM virtual machine using VMware Player. Okay. So let me show you a small VMware Player. So I already have virtual machine, which is already installed in my system, but that is not properly connecting to my network. So I will show you that later. So how exactly the virtual machines looks like, I will show you. But most of the times nowadays, we are not following that concept. Okay. So if you want to see the virtual machine, we have VMware Workstation. So I already installed this Ubuntu Linux virtual machine. Just for your understanding, I'm showing you. I'm not recommending to install all these things. So this is a VMware Workstation. This is a small software which is available. So with this software, we can run the virtual machine. So on my Windows operating system, I have already installed Ubuntu virtual machine. So it is free virtual machine. We can download and you can install. But this is not necessary to install. Okay, just for your information, I'm just showing you this. So I'm just running this virtual machine. So you can see on my Windows operating system on top of Windows, again, I'm running my virtual machine. So this is a Ubuntu virtual machines. So once it is booted, then I will show you how exactly it will work. So the virtual machine is nothing but we can have multiple virtual machines. The virtual means whenever you want to start the machine, you can start, and whenever you want to stop it, you can stop it. And all the virtual machines hosted by some other operating system. So on the single physical machine, you can maintain the multiple virtual machines. And again, the problem with the virtual machine is what? Again, this is also costly. So creating the virtual machine by taking virtual machine software is again some process is involved, and also in the real time environment, it will be costly. But for free users, you can find some demo operating systems. But when I use that in the real time, there are some licensing legal issues will be there. So they have to buy licenses, and accordingly they can create a virtual machines. Okay. So this is a virtual machine. Virtual machine means one system, one hardware we can share across multiple virtual machines, which are running on your single system. And this concept was also there in the market from the long back. So many years people were started using this concept for virtualization. So instead of uh, setting up the physical machines, they can set it up the virtual machines. Okay, and the virtual machine is having their own operating system, and that machine will share our uh, hardware part. So like whatever, suppose for example, your host operating system is currently using 16 MB RAM, right? So in that 16 MB RAM, we have to allocate some MB to this particular virtual machine. So this is our virtual machine. So this is a Ubuntu Linux operating system. In this also we have a browser, and in this also we have a Firefox browser. So multiple options are available. Just like normal how operating system works, similarly this operating system also works. So like this, we can also create multiple virtual machines on your local system. And currently this virtual machine is not connected to the network. So that is the reason I'm not able to show you this clearly. If possible, later I will try, okay? Selenium. Yeah, no internet. Okay. So this is how we can have virtual machines in our local systems, okay? So this was the concept earlier we were using, but nowadays this concept is also not used because the virtual machine concept is also very cost. So I'm just shutting down this. Whenever you want to start it, you can start, and whenever you want to shut down, you can shut down this. So you can maintain the multiple virtual machines in one single host. But the prerequisite is the host operating system should have a higher configuration, and then only it will able to host multiple virtual machines, because the same hardware configuration will be shared across multiple virtual machines. If you keep on adding more virtual machines, if you keep on running multiple virtual machines, obviously the performance of your system also will be reduced. That is another drawback when I use virtual machines. The performance of the system should be automatically becomes poor when I use multiple virtual machines. Okay. So that's the reason this concept was not preferred. So when I work with the grid concept. So what is a grid concept? In the last class we have discussed. There will be one hub node connected with multiple nodes. There is one hub server which will connected with the multiple nodes. Node is also another systems which are also having their own browsers. And whichever node we want to run our test cases, we can run it. That's a grid concept, right? So to set up the grid process, we need a hub and also we need a multiple nodes. So to replace this virtual machine concept, there is another concept came into picture in the market that's called containerization. It's called as a containerization. So first one is virtualization. Means what? Virtual machines we can set up. Containerization means we don't need to set up any virtual machines. So how the containerization works is basically we will have a containers instead of virtual machines. So before understanding the container, all these things, we need to understand something about the Docker. So what is a Docker? Docker is a concept which will follow containerization, which works based on the containerization. The Docker concept will work based on the containerization. So what is this containerization means? How exactly the Docker works? So we don't need to set up any systems, or we don't need to set up any virtual machines. It is very easy to do that. So how we can do this is how exactly the Docker works. We have something called Docker Hub. So there is a website, official website for Docker Hub. I'll tell you what is this, okay? Docker Hub. This is a website. This is a remote, we can say remote repository. We can also use call as a repository. Docker Hub repository. Repository means what? All the stuff will be maintained in one single place. That is called repository. The general meaning of repository is what? We can maintain all this stuff in one single place is called repository in technical terminology. So Docker Hub is a repository. What does it mean? The Docker Hub maintains n number of Docker images. N number of Docker images. We can simply understand image is nothing but a software. Okay, so just for your understanding, I'm simplifying this. Image is nothing but a software. So normally, if you want to install any software, we will download the installer, and by using installer, we will install the software, right? Similarly, to get the machine, right? We need, if you want to get some operating system or if you want to get some environment, the Docker Hub will maintain multiple images. So the Docker Hub will maintain the multiple images. So who will create these images? Again, there are number of people will create the images and they will push them into the Docker Hub. So somebody is pushed some images into the Docker Hub. Somebody else, they can pull those images. They can use it for our testing, development, and other purposes. So the Docker Hub, so many people will pull the images. So many people will push the images. Push is nothing but what? They are already created some images and they will upload them into Docker Hub for other purpose, for other people, they can use it. And pull is nothing but what? The images already there in the Docker Hub, and we'll pull the image, then we can use it for our testing or development. So some people will push the images, new images to the Docker Hub. Some people, they can pull the images and they can use it for automation. Because if you are using something that should be created by somebody else, right? Otherwise, we cannot use it. For example, Eclipse. Eclipse is a software which is created by somebody else. We are using it. Similarly, the images also will be created by somebody else. They pushed them into Docker Hub. And as a user, we can pull that image and we can use it for testing or development. So that's how the Docker Hub works. Let me go and show you. Let me complete the concept. Till I complete the concept, don't ask any questions. Just listen. Okay. What is image? What is container? I will come to each and everything. I'll explain step by step. Okay. So let me show you where we can access the Docker Hub. So if I go back to the website and you can simply say Docker Hub, just search for Docker Hub and you will see the official website. You can see here dockerhub.docker.com. And if you open this website, you can see this is official website of Docker Hub. So from this Docker Hub, we can download different images, whichever operating system you want, okay, and whichever environment you want. All this stuff we can download from this Docker in the form of images. Okay, so what is a Docker Hub? Docker Hub is a website repository which maintains a number of images. That's the first point. So I can say Docker Hub. Okay, so Docker Hub is basically a repository which is having what? Multiple images. So it will maintain the multiple images. Let's say this is one image. Let's say Ubuntu operating system. This is Windows and this is a Linux, and different images they will maintain in their Docker Hub repository. This is the first. Okay, what is an image? So image is something from that we can create a container. So there are only two terminologies you have to remember in this. One is image, one is container. So by using this image, we can create a container. So simple way we can understand. If whenever you want to install any software, we will download it, right? So the downloaded file, most of the time it will be executable file, right? Suppose some software, let's say XYZ software you want to download. So you will download the executable file. Once you download it, then you can double click on exe file and they will install the software, right? So once you install the software, you will able to work on the software. You will able to access it and you can use the software. Similar way, Docker Hub is provided multiple images, but these images we cannot directly use. So once you get that image into your local system, like just like a downloading executable file, right? Similarly, the image also we will download. And once you download the image, from that image, we will create something called container. Okay, so this container we can access. We will work on this container. For example, let's say I have some Linux images there, Linux operating system image, and I can get that image from the Docker Hub. So once you get this image, from this Linux image, I can create a Linux container. And this container will act as a Linux operating system. So we will work on this one. So just like an executable file. So once you downloaded executable file, we will install the executable file, then application will be up and running, right? Similarly, we will get the image file. From the image file, we will create a container. So once the container is available, we can access this container. So we can work on this container. We can run test cases on this container. Okay. So the Docker works based on the image and container. So image is nothing but something which will be downloaded or which will be getting from the Docker hub. And once you get an image, and from that image, we will create a container. So we will directly access the container. So containers is following the different concept called containerization. So this will not share our hardware. That's the most important. But in the virtualization, the virtual machines will share the hardware. For example, this is your actual host machine. Like this is your host operating system. This is one virtual machine. This is another virtual machine. This is another virtual machine, right? So this will actually share the center. Suppose here it is a 16 GB RAM. We need to allocate 2 GB, 4 GB, 4 GB. We need to split them into multiple virtual machines. But in the containerization, it will not share anything from your hardware. So the container is having their own kind of a memory, their own kind of a hardware and everything. So that is the reason the performance is also very good. And at the same time, whenever we want this container start and stop, we can do it. Whenever you want to have this open system, we can start it, we can stop it, or we can also restart it. So the complete control which we have in this container. So this is called containerization process. So from the Docker Hub repository, we will get an image first. So once you get an image, from that image, we will create a container. So once the create a container is got created, this particular container, we will able to access through our automation, and we will able to run our test cases on this container. So in the Selenium Grid concept, we need at least one hub, right? And multiple nodes we need, node 1 and node 2 and so on. So this hub is also we can download from the image, because these are already they kept in the Docker. The Selenium guys, they already created some images for automation Selenium. They kept there directly inside the images. So for hub, we will get one image. And for nodes, we also get multiple images, and then we can container. So hub is also running on one container. Nodes also running on different containers. Everything we will use only from container. So we are not making our local machine as a hub. So that for hub also, we will get one more container. And from there, we will start executing the test cases. So the hub, nodes, everything we will get it from the images itself, especially for the grid component. Okay. Now, this is a basic understanding. So how to set up, how to download, how to create an image, how to create a constraint, everything I will show you step by step. Just have some patience, okay? So first we need to understand theoretically, then we will move on to the practical part. Okay, so one image, we can create one container. Okay, so there will be one image, we can create a one container. Clear, everyone so far? What is Docker? What is Docker Hub? What is image? What is container? Practically, I will show you how image looks like and how container looks like, how we can create all these things. So this is just a replacement of virtual machines. Instead of using virtual machines, we will create a containers. We will get the images from the Docker Hub. Once we get an image, from those images, we will create a containers, and those containers, we can use it in our grid environment. Okay. So now to do all these things. So to access Docker Hub, images. And if you want to look at what are all images are available in the Docker Hub, you can go to their official website. So I'm just going to Docker Hub, and you can see search for Docker images. If I go here, and here you can search for, you can just select the images checkbox. And here you will see the different Docker's images are available. So for example, for Selenium, just search for Selenium. So whatever the images are required for Selenium, so they are already kept here. You can see Selenium, Node, Chrome. This is for Firefox, because this on this container, Firefox, these are all Linux machines most of the times. So in this, we have a Chrome browser, we have a Firefox browser. Okay, and we have also, to create a hub, we also have a Selenium hub container. So we can download this directly and we can make it as a hub. And suppose Selenium slash node Chrome. So this we can download, we can make it as another node, which is running Chrome browser. And suppose you can say Firefox, Selenium slash, you can also find somewhere node hyphen Firefox. You can see this also, we can make it as another container. So in which Firefox browser is running. Most of them all Linux operating system. So like this, whichever image we want, we can download the images from this Docker website. Okay. Now, so to do all these things, so to create, to download this image, and from the image, we have to create a container, right? So to do this process, we have to install Docker software. So Docker for desktop. So the software is available, which we need to download. So why we need to download the software? Because through the Docker software, we will manage all these things. We can get the content, we can get the image. We are not physically downloading them. Remember this, we are not physically downloading them. Only through Docker commands, we have to get the image into local system. From that image, we will create our own containers. And everything is possible only through Docker commands. There are some commands are there, image related commands, container related commands. So by using those commands, we do all this process. But to do this, we need to install Docker software. So I'll show you how to install Docker. It's very simple. You can simply say download Docker. And whichever operating system you're working on, all operating systems, the Docker will support. Just go to their website, and here you can see there are multiple options are there. You can see download for Windows, download for Mac. And in the Mac, again, Intel chip, Apple chip, there are two options are there, and download for Linux. So almost all operating systems are supported. So we need to just download for Windows. Once you click on this, it will start downloading the software. So once the Docker software is downloaded, it is a free, everything is open source. And once it is downloaded, you can see the executable file under the downloads. You can see here, I already downloaded Docker desktop installer.exe. So once you downloaded this exe file, you need to start installing the Docker. So I already installed. I will share the steps, how we can install step by step with the screenshots. You guys also can follow the same thing. So let me go to the Docker setup. Yeah. So this is the Docker installation process. So this is the icon you will get once you go to this link and download the software. So once you go to this link, you will able to download. And once you download the executable file, just double click on it, and it will show you some few windows like this configuration, add shortcut to desktop and everything. You can simply say OK. Then it will start installation. This is the latest version of Docker I have installed recently. So this will take some time to install, maybe 1 or 2 minutes. And once it is got successful, then you will see final screen like this. Installation succeeded. Okay. And once installation is succeeded, just click, you can close and restart button. So once you close and restart button, once you click on close and restart button, your system will be rebooted. So after installation is successful, Docker installation is successful, then your system should be rebooted. Your system should be rebooted, the whole operating system. Once it is rebooted, okay, you will get one icon on your desktop. So I will show you desktop icon. So you can see this is the icon. Okay, so this icon you can see on your desktop. So after rebooted your system, you click on this icon first time. So when you click on this icon first time, it will ask you a few details like this. Finish setting up Docker setup. So it will ask you a few options here. You can say select use recommended settings and then click on the finish. But before the screen, it will ask you for your profession and everything. So you need to select the student, because student explorers like tech educators, for them, the Docker is free. But when you're using Docker in the company's level, they have to buy the license. But for us, for practice purpose, for learning purpose, everything free. So before getting the screen, they will ask you some information about your profession and how to use the software. You can select all those options and then click on the finish. So once you click on the finish, the Docker installation was successful. Okay, once the Docker installation is successful, then you can verify the Docker version. Docker is successfully installed or not. We can execute these two commands. So because I already installed my Docker, so I'll open my command prompt. So in the command prompt, I can execute this command. Docker, all are lowercase characters. The Docker is a command, lowercase. So Docker version. So once executed this command, so you will see this error during connect. This error may indicate that Docker daemon is not running. So sometimes you will face these kind of an errors. So in this particular case, what you need to do is you need to go to Windows services. Okay, so in the Windows services, you will find something called Docker desktop service. Okay, so you need to restart this. So first you can just stop it first, and you need to again start. Okay, so once you start and stopped, so your Docker will start running. Even if you start and start service, even if it's still not working properly, then you have to reboot your system once again. So close this and try to launch your icon also. So this is the desktop I have already installed, right? Let me launch it. Okay, so now the UI looks like this. When you click on the Docker icon, so on the desktop, the UI looks like this. So currently it will show you the containers information and images information. I don't have any images as of now. Even in the containers also, I don't have any containers. Okay, so we need to check the version as soon as we have installed. And if you are getting error, you need to restart the service, then go to command prompt. Okay, so once you go to command prompt and just type once again, Docker version. Okay, now we can see, you will able to see the client as well as a server. Both you should able to see. Okay, client, Docker client and Docker server. So the server information, everything will show you. Okay, sometimes if you face any errors, go to Windows services and restart the Docker service. Okay, this should be up and run. Very, very important. And some more basic commands are there, so we can also cross check. And apart from this Docker version, there is one more command. It should run Docker compose version. Docker-compose is another command. So you can say Docker-compose. This is also important. Docker compose, then version. Docker compose version. So this will also show you Docker compose version. So these two basic commands should work properly at the initial stage. And then only you will come to know the Docker is properly installed or working fine or not. Okay. So this is a first step. So we have to successfully install the Docker, and we can verify the installation of Docker is successfully done or not. So apart from this, we can also get the UI, Docker UI. In this, we can see what are the images we have downloaded and what are the containers we have created. So we can get from here. And we can also start and stop images or containers from this UI. And through the commands also, we can do that. Okay. So currently I don't have any containers, and also currently I don't have any images. Now, so we'll see some basic commands, how exactly the Docker commands works, because how we can get the image from the Docker Hub, how we can create a container, and what we can do, what are the different operations we can do on the images and containers. So we need to know some basic commands. Okay, then we will go on to the Selenium Grid. So once your installation is successful, then the second step will start. So we can verify this command, Docker version, and then Docker compose version. So these commands should be successfully executed. And then we need to understand few Docker commands. So all the commands are divided into few parts, like basic commands, images related commands, and container related commands, some system related commands. So system related commands, most of the times we don't need, but mainly we need to know the basic commands. We have to know some basic commands, and then image and container command. These are the most important commands. Okay. So let me show you now how we can use those commands step by step. So we already installed Docker, and all the Docker operations we can do only through commands, but only few things we can do from the Docker Hub desktop application, because we can see the images, we can see the container, or we can stop the containers, we can start the container. So these things we can do from the Docker desktop, but rest of the operations we can do only through Docker commands. So now I'll show you some basic commands. Later I will share all the list of commands you guys can practice. So I'm trying to open my command prompt. So all the Docker commands we have to execute only through command prompt. Okay. So first we will see some basic commands. So as I already told you, the first command is what? Docker version. And this command will show you the Docker version, whatever currently installed. If the installation is not successful, or if the Docker service is not properly running, this version command will give you error. So currently my Docker service is properly running. If it is not running, go to Windows services and execute from here, restart from there. This is one command, and there is another command, docker-v also. So this will also give the Docker version number. So when I say Docker version, it will give you client and server, both information. But when I say Docker-v, this will give you only Docker version. And similarly, if you want to know the Docker info. So this command will provide you all the information about the Docker. So you can see the information about the Docker. So we can't understand all these things, but still we can use this version and context debug mode is false. There are what are the plugins are installed along with the Docker. So other stuff, some more information, detailed information will be displayed. Okay, and there is one more command. Suppose if you want to know you want to get help. Suppose you don't know some particular command, and you want to get the help of that particular command, how to use. So the help command also will be used. You can say docker -help. So this command you can use. So in this, what are all Docker commands are provided. So it will list out all the commands you can see here. So these are all common commands, management related commands. Okay, and some more commands here. So all the list of commands, and along with the commands, what are the options we can use. So all the information will be displayed. So docker -help. So this is one command. So these are basic commands, very, very basic commands. And if you want to work with the images and container, we have a special type of commands. And suppose in the login Docker Hub, if you are already created sign up and you will have an account. Okay, so but suppose in the real time, if you are working anyway, you have to create an account. So if you have that account login information, so from the desktop here also you can log into the desktop. So for example, you have another command called docker login. So this command will ask you I already executed this command earlier. So I provided my username and password. So it is not asking anything. Authenticating with existing credentials, login is successful. So this command will try to log into the Docker. So this is optional, not mandatory. If you created your sign up here, and if you have an account, you can log in, or else you can ignore. Even without login also, we can still use it. So these are all some basic commands, very basic commands. And then I can clear this. Now we'll see images related commands, how we can get the image from the Docker. Okay. So for example, let's go back to the Docker Hub. So from where we will get all the images, this is the location. From here, we can get all the images. So for example, I'm trying to get one Linux operating system image. Ubuntu is the most popular Linux. So I'm just selecting this. Okay, Ubuntu. So this is Ubuntu is one of the image which is available in the Docker Hub. Now I want to get this image. So we have to use certain image related commands to get the images, and from the image to create the container. This is a step-by-step process. First, we will see the images related commands. So you can also open the Docker desktop application parallelly so that you can see all the images here. Whatever we get the images from the Docker Hub, you can see all the images in this location. So currently, if I look at the desktop, I don't have any images. Okay, suppose if you want to see what are the images are already there in your system, simply you can execute this command, docker images. So this command will show you what are all images which is already downloaded earlier. So as of now, I don't have any images. No repository tag is nothing but a version number, image ID, when it is created, size of the image. So that information should be displayed. So currently I don't have any images. So when I execute this command, it is not showing any image related information because I don't have any images. So now I want to pull one image from the Docker Hub. So how to pull the image from the Docker Hub? Very simple. Docker pull, and then we have to specify the name of the image. So which image you want to download? I want to download something called Ubuntu image, Ubuntu Linux image. Simply you can say Docker pull Ubuntu. So when I say enter, it will start downloading the latest version by default. It is trying to download the Ubuntu image. So now it is successfully downloaded. So again, if you want to see Docker images, Docker images. So now you can see this time it will show you the Docker. You can see Ubuntu latest version, this image ID. So 8 days ago it is got created, and then size of the image. So at the same time, you can see the UI also. So you can see previously we don't have anything in the under images section. Now we can see the Ubuntu image. This is how we need to just download the image from the Docker Hub. Whichever operating system, whichever browser environment, any type of image we can download from the Docker. So what are the commands? Docker images. This will show you the existing images on your system. When I say Docker pull, then specify the Docker image name that will pull the image, and that is maintaining in the system. So when I say Docker images, you will see all the information. Okay. Suppose I want to just remove this Docker image. I already downloaded this image, but I don't need this image. I just want to delete this. Simply what you can do is you can delete this through command, or you can delete it through this UI. So from the UI, you can see the delete option here. You can click on this delete. The image will be deleted from the UI, or else here we have one command called Docker. Docker. You can simply say, so when I say Docker images, it will show you current images, right? So from this, we will get an image ID. So if you want to delete this image, we need this image ID. So how we can delete? Simply you can say Docker RMI. This is a command. Remove image. RM is nothing but I is representing image. Remove RMI. That means remove Docker image and space give image ID. So this is the image ID I have currently. So I just put it here. And this will remove the image. So once it is removed, again, if you type Docker images, no, you're nothing to see here. So these are the few basic. Again, if you go back to the UI, under images, there are no images are available here. Okay. So these are the basic commands. So 3 commands we learned. Anyway, I will provide the notes later. So the first command is what? Docker images. So this will display all the images which are available in our system. Next one, Docker pull image name. Right? I can say image name is what? Ubuntu is specified here. So that means it will download the Docker image. After that, if you want to remove it, Docker remove image, and then here we can specify the image ID. Image ID we can specify. So these are the 3 commands which are related to what? Images. Images commands. Docker images will display all the images which you have downloaded. Docker pull Ubuntu. So this command, Ubuntu is a just image name. Whichever image name is specified, that image will be downloaded. Docker pull. And if you want to delete existing image, we can execute Docker RMI and then image ID. So from where we will get image ID? When you execute Docker images command, that will show you existing Docker images. From that, you can capture the image ID, and that image ID you can pass it and you can delete it. Okay. So these are the 3 commands which are available related to images. So these 3 are clear. Everyone, please confirm in the chat box. Now I'll move on to the next one. How to download image from the Docker Hub. Is this concept clear? How to get the image from the Docker Hub. This is the first step. Okay. Now, so once you know about images, now let us move on to the containers, because images we cannot directly use. From the image, what we need to do, we need to create a container. So that container, we can use it for testing and automation. So now we will see the container commands. This is most important. Okay. Container commands. Okay. So in the container, we have again few commands. So the first command is Docker PS. So when I execute here, I'm just clearing this. Currently, are we having any images running as of now? No images, right? So when I say Docker images, because I already removed existing image, whichever I have downloaded, I have removed it. So I don't have any images. Okay. Now, if you want to see what are the containers are there in your system, what are the running containers? So simply you can say Docker PS. Docker PS. PS is a command. So this command will show you what are all the containers which are already running. So some containers are available, but they don't run. They are not currently running. So those containers which don't show here, it will show you just the containers which are currently running. So when I execute this, so it will show you container ID, image name, command, creator, status, ports, names, and everything. But I don't see any kind of containers running here. But if any other containers are currently running, this command will show you the list of containers which are currently running on your system. But remember this command later again, I will use it once you start the container. So Docker PS is one. So this command will show you what are all containers currently running on your system. So currently I don't have any images. I don't have any container. So it is saying empty, simple. So now how to create an image? So before creating an image, what is the prerequisite? Sorry, before creating container, what is the prerequisite? How to create a container? From where we will create a container? We need an image, right? So we should have image first. From the image, we can create a container. That's the prerequisite. So if you have a image, then we can create a container that we already know. So for example, again, I will pull one image. Observe very carefully. Docker pull Ubuntu. So I'm just getting the image first. Okay, again, it is trying to download the latest image. Okay, now I have an image. If you look at, you get Docker images. Yeah, now I have an image. So from this image, we want to create a container. So how to create a container from this image is very simple. Docker run. Docker run is a command. Docker run. And here we have to specify image name. So what is the image name is here? Ubuntu is a image name. So I can say Ubuntu. So Docker run Ubuntu. So this is how we can create a container. So from the Docker run is a command and specify the image name. So because we already have this image, so by using this image, it will create the container. Suppose if you do not have an image, for example, if you don't have an image, I'm directly trying to execute this command. Then what happens is this particular command, it will check this image is already present or not. If it is a present, by using this image, it will create a container. Suppose if the image is not available, then this command will get the image first. It will automatically download the image. Then it will create a container. That means the Docker run command will do two tasks. One is it will download the image. From that image, it will also create a container. Both the jobs it will do. But if image is already exist, then it will not do download the image. It will directly create the container. Understood my point, everyone? So Docker run is a command. This will create a container by existing image. Suppose existing image is not available, then it will get the new image. From that image, it will create a container. Understood my point? So when I execute this, it will create a container. Docker run Ubuntu. Docker run Ubuntu. So it is already created a container. So if you go back and see UI, so this is my image. Now if you go to the container section, see this? The new container is got created for Ubuntu image. This is called container. Currently, this container is not running. So that's the reason exited status is there. It's not running. So if you want to see list of containers, Docker PS command I told you, right? So still it will not show you. Why it is not showing here? Because the container is just created, but we are not running the container so far. We haven't run the container. The container is just created. So the command Docker PS will show you only running containers. Only running containers. Okay. So Docker PS will show you the running containers. The second command is Docker run and Ubuntu. So this will create actually a container. These are the two commands which we have. Suppose if we want to start the container, we use another command called Docker start. Docker start. And if you want to stop the container, we use a Docker stop. So again, we need to specify the container ID here. Okay, Ubuntu and Ubuntu. So these are the few commands which we have. And if you want to remove the Docker, so Docker rm, and here container ID we have to specify. Container ID or container name also fine. Container ID or container name is specified, that will remove the container. So these are the 3, 4, 5 commands are there. So Docker run will just create a container, but it will not run it. It will not execute. And if you want to start the container, you have to use this command. Docker start Ubuntu, Docker stop Ubuntu. So these two commands will start and stop the container. And if you want to remove the container, this is the command we have to use. Docker rm container ID and name. So let us use this command. So as of now, my container is got created, but it is not started. It's not running actually. So if you want to start this, you can directly start from this. You can see there is arrow mark start. From the UI, you can start. And we can also do multiple operations here. So we can say view details and other information. If you want to delete this container directly, you can delete from here. And most of the time we can do through commands also. So again, go to the command prompt. So now I want to start. Currently, it is not showing any process because it is not currently running. Okay, so if unless we know the ID, we cannot do this. So what I will do is Docker container is there, but I want to interact with this container. So to interact with the container, as soon as you interacted with the container, then container will stop, container will start and keep running. So let me show you how we can interact with the container. Is very simple. Same command again, Docker run -it, then Ubuntu, specify this. So this is optional command. This is just for interacting with the container. So Docker run -it, Ubuntu. As soon as you run this command, you can see, you will see the Linux prompt. You are already connected to the container. Then that's the reason you are able to see the Linux prompt. So here you can execute all the Linux commands. And parallel, if I go back and see your container, see in the container section, this is create a new container again. So previously we created one container using run button. It is just created. That's it. Is not running. But again, I have created another container. For one image, we can create multiple containers, guys. Remember this point. I forgot to tell you. For one image, you can create multiple containers. If you have a one software, you can install it in multiple places, multiple times. Similarly, one image, we can create multiple containers. So here again, I have executed this run command. So it is started my container. It is also running here. Okay, if you want to stop this again, because this container is running, right? So what I can do is I can open another command prompt. So without disturbing this, and execute the PS command. If you look at the PS, so what PS will do, it will show you currently running containers. See, now this is a container, currently it is running. Now, if you want to stop this container, stop. I don't want to remove, but I want to stop this container. Simply say Docker stop space. You can specify the image name or you can specify the container ID. I'll say container ID. Then it will stop the container. Docker stop container ID. So it is got stopped. So again, if I execute PS, Docker PS, nothing to show. If I go back to the desktop option also, go to the containers, see this is got exited. Second one is got exited. Again, if you want to start, same command. So here, okay, so instead of stop, you can say start. Again, container ID is required. So now it is got started. Now you can see it is running here. Okay. So Docker ps command will display what are all containers currently running. Docker run Ubuntu. This will create a new container by using existing image. If existing image is not available, then it will pull the image, then it will create a container. And it will start the container, start command. Stop command will stop the container. And if you want to remove the container, then you can use rm command. Let me remove this. So go to the prompt and docker rm and container id. So this is our container id. So that you can specify. And also you can execute this command, or else you can directly remove from the Docker. Go to containers, and from here you can click on this delete button. So it will automatically delete. So or else you can do through command. So what is saying error response from because currently this is started. Currently it is running, right? So if the container is running, we cannot delete directly. We have to stop the container first. So to stop the container, I'm executing this stop. So once it is stopped, then you can execute the rm command. So once it is stopped, then I can remove the container. So now it is stopped, then I can execute this remove command. Docker rm image id. So now it is got deleted. And if you go back and see your UI, so now this new image, new container is got deleted. Okay. So these are all container related commands. So Docker PS will list out all the running containers. Docker run is a command which will download, which will create an image using existing, create a container which by using existing image. If the image is not exist, then it will pull the image first, then it will create a container. And the start command will start the container, stop command will stop the container. RM is a command which will remove the container based on the container ID and name. So these are all container related commands. Now everyone is clear on this? Yes. So Docker run command will create a container by using existing image. Suppose image is not available, then it will pull the image automatically, then it will create. Everyone is clear on this? Please confirm in the chat box. Yes. By using this run command, yes, we can bypass this command. So pull command, we can bypass or we can skip it, because Docker run command directly is downloading the image, right? So it will download the image. By using the image, it will create a container. So this is the direct command. It will download the image. At the same time, it will also create a container. But when I say Docker pull, it will just download the image, but that will not able to create the container. Okay, these are all container related commands. So some more system related commands are there. It's not much useful. For example, let us say, I'm just closing this. So for example, if you want to know the Docker statistics, like how much memory it is used internally, like how much CPU and how many containers and how much CPU memory it is utilized internally. So you can use this command Docker stats. This is a command which is available. So currently it is not using anything because we don't have any images, we don't have any containers. If you have images and containers, it will show you information what are all containers and how much CPU percentage it is using and how much memory it is using. All the details it will show you. And similarly, so there is another command Docker system df. So it will show you like a disk usage related by Docker. So for example, let's say Docker system df, it will show you how many images are there, how many containers are there, okay, how much size it is using, all the information it will show you. Docker system difference. Display disk usage related to Docker. Earlier, we already created images and containers, right? So it will show you that information. Currently, it is not there. So this is one more command. So these are few commands which are available in Docker. There are so many commands are there, but I'm going to very basic commands which are very related to our automation. Okay, suppose there are so many containers are running. There are 5 to 10 containers are running. I want to remove all the containers. I want to remove all stopped containers one shot. So then we have one more command here, Docker system prune, Prune hyphen F. F is representing forceful. So this particular command will forcefully remove all the containers which are stopped, because there are different containers. I want to remove them. So individually it will take some time, right? So Docker, RM, then image ID. That command we have to execute 5 times. Instead of removing individual containers one by one, I can also remove all the containers in one shot by using this command, Docker system prune hyphen F. So when I execute this command, it will delete all the containers currently which are running on your system, even networks, whatever is you created from the Docker, everything will be removed and everything will be fresh. So these are all system commands, we can simply say. So mainly images commands and doc container commands are useful. Some basic commands also there, which we already discussed. Under basic commands, we have uh, Docker version here. You can say Docker version and a Docker hyphen V also there, and Docker info, information about the Docker. Docker hyphen help is another command we have. Docker login we have. So you can just explore this command later. I will just provide the list, and also I will share the document. And images command, container, mainly images and container commands are most important. And then system related commands. So under system related commands, so again we have Docker stats. So Docker stats is a one command. So Docker system df. And to remove all the stopped containers in one shot, we have a Docker system prune hyphen F. This is another command which we have. So all the commands are in lowercase characters. Remember this, but in the document, somehow you will able to see this. The document you can see uh, uppercase characters sometimes, but all the commands are lowercase. So these are the basic commands. I have given examples also. You can try this. Container commands and system commands. Okay. So start Ubuntu start is a command which will start the container. Suppose if the container is there, it is not running, right? If you want to start the container, you can execute this command. Docker start, then name of the container. Sorry, this ID of the container, name of the container. So here I can say ID, container ID, or container name also you can specify. Here, container name is different, image name is different, guys. Okay. So better to have container ID instead of, or else you will confuse. Here also we specify container ID. So here also we specify everything is operated only through container ID. Container ID. So how we will get the container ID is by using PS command. Container ID. RM also we specify the container ID. Okay. So these are all container related commands and images related commands. So everybody is clear so far. These are basic commands. If you know, that is enough. So now we will move on to the automation. How we can pull the images, how we can create a container, we understood. For automation purpose, we will download some images, we will create some containers, then we will run our automation test cases on those containers. Okay. So to do this, what we need to do is, let me share the document. So what are the containers we required for our Selenium automation? So I will try to download 3 containers mainly. So 3 containers, all 3 containers are based on Linux operating system. So one is for creating hub. Second is one what Linux. On this, I have a Firefox browser. Another one is again Linux, which is having Chrome browser. Okay, for hub, I will download one container, one image, and another image Linux Firefox, another image Linux Chrome. So 3 images I will download. 3 images I will download. And from those 3 images, I will create 3 containers. And then we will run our automation test cases on those containers. Okay. But again, these 3 should be part of one single network. We need to first create one network, and then we need to add these 3 containers to that network so that every container will be communicate each other. So these three images we require, not containers. First images we need, right? So we will download these three images. And once you download it, then we can create a containers, or else we can directly create a containers because we have this command, right? Docker run command. So when I use this command, it will automatically download the image, and also it will automatically create a containers. So that's the reason we can directly use this command instead of pulling a separate. Okay. So for nodes, we need image. So this is another image. This is another image. This will I will use as a one node. This is I will use as another node. So one hub, two different nodes I'm taking. Okay. Two different nodes I'm taking. So this is one image. This is another image. I'm trying to use them as a nodes. You understood my point? So three images I'm trying to get from the Docker Hub. One image I'm trying to use as a hub. Another image I'm trying to use as a Linux Firefox. This is one node. And another image, Linux Chrome, that I'm going to use as another node. So one hub, two different nodes totally. So first we can download the images. From there we can create a containers, or we can directly create a containers by downloading the images by using Docker run command. I already discussed the Docker run command will create a containers based on the existing image IDs, right? So it is not a container ID. This is an image name. Okay. So this command will create a container based on the existing image. Suppose existing image is not available, then it will pull the new image, then it will create a container, right? So we can also use Docker run command directly. So let us set up this three images now in the Docker. So as of now, I don't have any containers. I don't have any images. So currently I have one image. So also I will delete this image directly from here. I can delete this image. Perfect. Now I don't have any containers. I don't have any images. So what I will do is I will run these three commands. Next, go to the next step. Selenium Grid setup with the Docker containers. So we need to first pull three Docker containers. Selenium Hub is one image. Selenium-node-Firefox is one another image. Selenium-node-Chrome is another image. So there are three images we want to download. And after downloading image, we can verify the images are there or not. And after that, we can create a containers. So by using this command, I will create a containers. Okay, if images are not downloaded, you can directly execute this command. Okay, you can directly execute these commands because the Docker run command will directly get the image and also it will directly create the container. So these commands are optional. If you are doing it, that's fine. If you are not doing it, still that's still fine. Okay. So because as a beginner, we will try to do this. So what I will do is I will pull the three images from the Docker Hub. I will pull these three images from the Docker Hub. So if you want to look at where exactly these images are present, you can say Docker Hub, go to search for Docker images. And here under images section, we can type a Selenium. Okay, you can say node Chrome. So this is one image I will download, Selenium/node-Chrome. So you can see Selenium/node-Firefox, Selenium/node-Chrome. So these are the two images and one image is for hub. Because we no need to have jar files and nothing because these nodes are already having grid setup. So we no need to anything, just we need to download, combine them and execute our automation. So we no need to put any grid jar file, nothing. So this is one image, this is another image, this is another image. So let's download these three images from the command prompt. So let's go to command prompt. Now step number one, I'm pulling the images first. Docker pull Selenium/hub. So this will pull one image that I'm trying to use it as a hub. So I'm executing this. By default, it will get the latest version. So this is the first image I'm downloading from the Docker Hub. Because if you directly run the direct run command, then what happens is, because when you run this docker run command, by the time image is not available, so it will take more time to download image and create a container. So that's the reason if you download the images before itself, then it process will be very faster. So that's another advantage. So now I'm pulling another one, docker pull selenium slash selenium slash node hyphen chrome. Okay, so this is another image I'm downloading from the Docker Hub. And what is this image contains? It contains a Linux operating system having Chrome browser. Okay, it is still downloading. I'll share this document later so you guys can go through the steps. Done. So now I have downloaded Node Chrome. Then I will download one more, Node Firefox. Even for Edge, Opera, all browser nodes are available. So I can just download. So now Hub, Firefox and Chrome. So one hub, two nodes. Totally 3 images I have downloaded. And once it is downloaded, we can check what all images are downloaded from the Docker Hub. And from the UI also, you can parallelly check. Now you can see, go to images. So as of now, I have 2 images downloaded. So now this is also downloaded. Now you can go back and see 3 images, Selenium Hub, then Selenium Node Chrome, Node Firefox. So 3 nodes are downloaded. If you want to see through commands, what you can say, Docker images. So this will also show you what are all images just now we have downloaded. Okay, so images are ready. So we verified images. So once images are ready, we have to create a containers by using these images. By using these images, we have to create a containers. And at the same time, those containers should be linked to each other, should be part of one single network. Okay, the containers are individually, images are downloaded individually. And we can also create a containers. At the time of creating the containers, we need to create them in the single network, because that's a grid, right? Grid is nothing but what? All the hub and nodes should be connected each other. If they want to connect each other, they should be in the single network, right? So we already have images. Now we need to create containers which are sharing same network. So for that, what we need to do is we need to execute sequence of commands. So this particular command, Docker network create a grid. So grid is just a name I have given to the network. Docker network create. This is the command. Docker network create. And here we can give a network name. You can provide any name, my network or grid network or anything. Some name is required. Because I'm setting up this environment for a grid environment, so I'm just giving grid is my network name. So once you created your network, then I'm running the first image to create the first container. Docker run. And here you can see Selenium slash hub. You can see this. These are the port numbers. I'll tell you what is this. And hyphen net, in which network you want to create this container. And here the name of the container, Selenium hub. I'm giving this name to this hub. And from which image you want to create this container, Selenium slash hub. This is the image. Okay, there are multiple parts in this. You need to understand few things. I'll tell you. In this command, there are multiple parts. The first part, here, this part is called specifying the name of the network. Same name you have to use. And this is the name of the particular node. So this will create one container, right? That is acting as a node. So for that node, I'm giving this name, Selenium Hub. And from where this will create a container is from the image. So this is called image. This is called image name. This is called name of the node. And this is a network name, because in the same network, we have to create this container. And what is this actually? What is the default port of hub? What is the default port of hub? In the last class, I have shown you. What is the default port number of hub? 4444, right? So what exactly we are specifying is sometimes what happens is if you run this on the same port, there will be some conflicts. So what exactly we are saying is we are taking the range actually 44442 4444 means 4442, 4443, 4444. So in between these three ports, it will allocate one of the port dynamically. So that we are assigning. This is a porting mechanism, and this is the name of the network. This is the name of the node. This is the image. So this will create a Docker hub node. Okay, Docker hub. Now the second command. By using the second image, Docker run. So again, network is grid. This is a network name, and this is the image name. So the by D, by -D and by -P is representing the process, and -D is representing this process will happen in the backend system. Okay, in the backend it will run because in the same network we have to create all the nodes, right? So that process will happen in the backend system. So that's the reason we have to provide some more commands, and these commands are captured from our Selenium website itself. These are not generated by us. We will get this from the Selenium documentation. Okay. And some more additional information we have to specify like this. So whatever port numbers you have used here, the same port numbers you have to refer 44422 to 4433. 2 to 4 we have mentioned, right? Between this 2, 3 also. So execute this command as it is. This will create a new environment, new network. The first command will create a hub. Second command will create another node. Third command will create another node. So basically these three are the containers. Containers we created, and also we connected each other. We connected all the containers for single network. What is the name of the network? Grid is the name of the network. So we are already created at the beginning. Okay, that is the meaning of these commands. So we can create containers, we can create and run the containers by using these below commands. Okay. So images already downloaded. Now we will execute these commands one by one. So what I'll do is I'll first go to the command prompt, and we already have images, right? I can say Docker images, but I don't have any containers. If I look at your Docker containers, you don't have anything here. Right. So now let us execute these commands one by one. First, we need to create a network. Before creating containers, we need to create a network because we need to associate all the containers to the one single network. So Docker network create. You can give any name to this network. I'm just giving grid. This command will create a network. So it will throw some kind of ID. So that means the network is got created. Now I'm creating the hub machine first. So by executing this command. So copy this command as it is, and then paste it over here. So this command will create hub, and it will start running. If I go back and see your container, see here under containers, our hub is running as of. It is running. Hub is running. Now, similar way, you can execute the next command. This one. We will create another node. Go back here and put it here. So if you're not able to copy them properly, first copy them in the notepad, because multiple lines commands are there, right? So better to copy them in the notepad because multiple lines are there in the same command. So just copy from here. What am I doing here? I'm creating a containers. Okay, it is copying in multiple lines. Okay, we'll do one thing. We will try to copy pieces, bits and pieces. First, we will try to copy this, or else you can make this full screen. Okay, so let us try step by step. So I'm just copying here, and then -E, and then rest of the part. And then space, and this is the part. Okay, so this is the complete command. So this command, invalid reference form, repository name, library SE event bus must be lowercase. Okay, E is pasted twice. Okay, so let me check run D -net grid -e. Yes, is run bus host Selenium hub. Okay, so here we have posted E multiple times. Okay, hub -e. Okay, -e. Yeah, perfectly fine. So this is the first command. So this is created one more node. If I go back and see here. So hub is running, another one is also running. Both are connected. And similarly, we have to run one more. So this time again, same command, exactly the same command. The only change is this one, Selenium/node -Firefox. So node -Firefox. Okay. So this will create another one. So now I have created these three. Hub I have created, Linux Firefox node is also created, Linux Chrome node is also created. So all three are currently running. And if you want to see through command, you can say Docker. What is a command? How to know what are the running, how we can display running containers? Docker PS. So this command will show you what all containers are currently running. So that means we have successfully set up grid environment on Docker by using Docker containers. We have set up the grid environment using Docker containers. So hub is ready, nodes also ready. Everything is running. Now, can we run our automation on this environment? Yes. So if you look at the console, if you go back and see the grid console, localhost 4444. Now you can see two environments are created, right? Two nodes are attached to the hub. This is one node. This is another node. You can see on the Linux, Chrome browser is running. On the Linux, Firefox browser is running. So if you want to see what are the nodes are attached to the hub, you can use this URL. Here you can check it. What are the nodes are added? What are the hub is added? So these two commands you can execute. And also I will put the first command, these two. Go back. Okay. So this is for creating the network. This is for creating the hub. This is for creating the node 1. This is node 2. So currently, how many nodes are attached to the hub? 2 nodes. So if you open this URL, go to the overview section. Here you can see currently, are we running any sessions? No sessions are running. In the overview section, you can see one Linux, which is having Chrome, and another Linux, which is also having Firefox. These are two different machines you can consider, two different nodes. Okay. Now, in whichever environment if you want to run your test cases, you can execute. So now go back to your test cases. Go back to your project. And we will create a new XML file here. I have created a new XML file, greedy Docker. So again, same XML file. You can also use mastered XML or any other XML file, no problem. Only thing is, we need to just pass the operating system is Linux. And on which browser you want to execute? On my Chrome browser, I want to execute. Linux operating system, Chrome browser. And if you go back to the base class, you don't need to do any change in the base class. So go back to the base class, because in the last class, I have not added Firefox browser. So just newly I have added here. Under, suppose if the environment is remote, then we have to set Windows, Linux, Mac, and it will decide the operating system. And here it will decide the browser. So Firefox browser. And this will not change. Hub URL will not change. In any type of grid setup, the URL still remains the same. Okay, no need to change anything on your test case. Only thing is you need to go to the separate XML I have created. So base class, we no need to do anything. Base class, same thing. We no need to change anything. Same URL, nothing, because we already done this earlier for grid environment, right? So same setup, no change at all. Just you need to go to XML file and on which platform, which browser you want to run, specify what are the test cases you want to execute on this environment. Okay. Now I'm running the test case. Just observe how it is going to execute. Yes. So you can also execute the existing XML files. If you want to execute master or XML, execute. Just specify the operating system and the browser. Accordingly, it will go. Okay. But for grid environment, we don't run test cases every time on the grid. So I'm just taking another XML file. So on Linux, Chrome. So on which node it will execute now? Linux and Chrome I have taken. I have two nodes. On which node the test cases will be executed now? In the first node. So Linux and Chrome. Okay, let it be open this. Now I'm running my test cases. Run two test cases I'm running. Run as test engine suite. So once you run the test cases, now go to the URL and look at here. Go to the sections. Now you can see one session is got created. On Linux, on Chrome browser, my tests are executing. We cannot see UI and everything because by default, it will follow headless execution. So execution is done. My report is got generated. Right? If I go back and see here, you will see operating system. On which operating system we have executed Linux and Chrome operating system we have executed. Two test cases are got passed. So now my test cases are executed on grid environment, which is configured with Docker containers. Now let me execute one more time. So currently there are no sessions are running. Again, my two nodes are free. Now again, go back to your XML. This time I want to execute in another node. So I commented this. Okay, now I'll enable Linux Firefox. This is another test. So this time I want to execute Linux Firefox, another node. This is another node. Again, two same test cases. So now execute. Run as test engine. Now we can go back and see the overview. The second node I'm executing, go to the sessions. Now it is going to create a new session and the test will be executed. See this? Now on the Linux, Firefox browser node is got created. Now test is executing. Now execution is done. And if I again go back and see, okay, I think two tests are executing. 1 second. Yeah. Because we have mentioned two test cases, right? So two times are executed. So this is account registration test, login test. For every test case, it will create a new sessions. So now we are executed on the Firefox browser. If I go back and see here, the Linux and Firefox browser executed. Now I want to execute all of them, both the nodes at the single time. So I enable this one. Also enable this one. So I'm executing the two test cases on Linux Chrome node, Linux Firefox node. Okay. Now run and see. Go back and see grid environment. Go to the sessions. See one session, it is created sessions one after another. See, this is Linux Chrome. Executed. One more time it will start. One more time. The report will be generated for test case wise. Okay, test wise. So one report is got generated here. The another report. So this is also executed. So one more report is got generated. See, in the first two test cases, we have run on Linux Chrome. Second round, we have executed both the test cases on Linux Firefox. Understood, everyone? So this is how we can set up grid environment on Docker containers. So we don't have any VMs or nothing. So once your job is completed, so if your runs are completed, then simply what you can do is you can stop all the containers. So to stop all the containers, or when you are done with your grid and containers have exited, the network can be removed with the following commands. But we don't execute this command every time. Let it be there. Just stop the containers. If you want to stop the containers, what you can do is we can just go to the Docker and here go to the container section. You can stop it here. The stop button is there. If you stop here, the containers will stop automatically. Okay, now it is got stopped. Suppose tomorrow again, if you want to run on them grid environment, then you can start these containers, again initiate the runs. So whenever you want to stop, whenever you want to start, you can control from the UI or you can do through Docker commands here. So currently, previously when I execute Docker PS, it will show you all currently running containers. But if I execute the same command one more time, nothing is running. So Docker containers have stopped. Okay. So far everything is clear. Please confirm in the chat box. So we have created Selenium Grid setup with Docker containers. By creating Docker containers, we run the grid environment on the Docker systems. Okay. In this approach, there is a problem. Okay. So there is some challenging we have. What is there? Every time we need to start and stop the containers whenever you need. And also we need to run these commands manually, right? These commands we have to manually. So which one is hub, which one is node, Chrome, Firefox node, we need to run these commands manually. If you need more environments, suppose I want to have Edge also, Opera also, and other Windows operating system, because we can have n number of machines as a nodes, right? So as soon as the number of machines are keep increasing, you need to execute more number of commands here. This is again manual effort. To reduce this effort, Docker is provided something called Docker compose.yaml file. This is the configuration file. Okay, in this, we can specify all the configurations, like which one we need to make it as a hub, nodes, everything we can put in this configuration file. And once you run this configuration file, your grid setup is ready. It is a very, very simple and shortcut way. I'll tell you. So what we need to do is, you don't need to do all the previous steps. You don't need to pull the images. You don't need to create a containers, and you don't need to attach them to the network. Just you can skip this step. We are just for our understanding, I have executed this, but real time, we don't do all these things manually. Simple way is we will create one configuration file, docker compose.yaml. Okay, it's very simple. This is just an alternative of the first approach, but this is a simple way. So what I've done is I already created this Docker compose. If you want, you can put this in the configurations. Under resources, I can put this file, docker compose.yaml file. Or else you can put here. Anywhere it is fine. So I can just remove from here for now. If I go back to the docker compose.yaml, this is a configuration file. So if I look at here, this is a hub machine. Network name is grid. And this is the one node machine. And this is another node machine. So similarly, you can add n number of nodes. Suppose tomorrow, if you want to add another node, copy this entry and just put it another entry like this. You can add n number of nodes like this. Very simple. You can add n number of nodes and just specify the name of the node. That's it. Okay. So once we have this configuration file, it is more simpler than previous approach. In the previous approach, what we have done is we have just done everything manually. We pull the Docker images, then we have created a containers manually, and then we have executed the test case. Now nothing. We don't need all those things. Just to create one single file. Okay, and run this file by using docker compose command. So by using this docker compose, we have to run the file. First of all, where we need to go is we need to save this docker compose file. And where is this file is present? Go to properties and go to the location first. So wherever the YAML file is present, go to that location. Open the command prompt. In the command prompt, you can cd, put this location. Now here, we use one command called docker-compose. Docker-compose start. And you don't need to specify the file name or anything. So the start command automatically execute this YAML file, and your grid environment, hub, nodes, everything will be ready. So whatever you have done this configuration in this file, everything will be ready. You don't need to do anything manually. Simple one single statement. Docker-compose start. I put this command here. Sorry, not start, up command, up and down. So up. So this will make our grid environment up. So I have executed. Now just observe. Yes, everything it is creating. Perfect. So node has been added here. Another node is also has been added. Everything is done. So just minimize it and run your test case. Go to your XML file, docker.xml file, and then execute. That's it. You don't need to do anything manually. One single configuration file will control everything. Now, if you go back and see the hub sessions are creating, you can see sessions are creating. Tests are also executing. See, one report is got generated. Again, another session will be created for second part. Yeah, another session is got created. So this time it is taken Linux Firefox. For second round execution, one more report is got generated. So grid environment become free. Fine. So this is very, very simple. Just execute this one YAML file through command prompt and run your XML file. You don't need to bother about Docker, but you need to install the Docker. Okay, without installation of Docker, nothing will happen. But the commands are optional. You don't need to execute even single command manually. Okay, you don't need to execute even a single command manually. So all these commands we have just simply be avoided. So these commands we have executed only through YAML file, configuration file, right? Simple ways, Docker compose YAML. This is the file we have to execute using Docker compose up. And you can, if you want to see the sessions are running, you can open this URL. And suppose if you look at here, one more thing. In the Docker, currently how many instances are it showing? Only one instance, right? Because at a time, we can run only one Chrome instance on Linux, only one Firefox instance on Linux. If you want to increase this number of instances, you can use another command. You can execute this command, Docker compose scale Chrome equal to 3. Similarly, Docker compose scale Firefox equal to 3. If I execute this command through command prompt, then what happens is, obviously, this number of sessions will be automatically increased. Okay, now let me execute this command through the Docker. So currently, how many are showing here? Only Chrome 1 is showing. So now if I go back to the command prompt, and then I'll execute this command, Docker compose scale Chrome equal to 3. So I'm executing this. So no configuration file provided. Okay, I think we cannot execute this command independently. We need to do this. Just a second. Okay, so I think this command separately works, not with the configuration file. Okay. So this is how we can do through configuration. So this is exactly the same setup you have to follow in iOS, even Mac operating systems. So what is the advantage of increased number of sessions? Sometimes if you run parallel test cases, you need multiple Chrome instances, right? On the same machine, you are executing two test cases on Chrome, but I want to execute them parallelly. Then two Chrome instances should be running, right? In that case, we can increase the number of sessions or else not needed. So in the Mac also, it is the same process, no change. In the Mac operating system also, you can download the Docker, same process, install the Docker. And once you install the Docker, then you can check the version and Docker compose version. And you should able to see these messages when you execute in the Docker version. If you're not able to see this, you need to start the Docker service. 99% of the times you will get an error when you get the version. So go to the services section here. And even if your services, it is up and running, but still it is not working, means you need to restart your system. Go to the Docker desktop service, you can say restart. Okay, once the Docker is got installed, it is automatically reboot or you need to reboot. And then practice some basic commands. And then Selenium grid setup with the Docker containers. This is manual process. And this is automated process. Selenium grid setup with the Docker compose YAML file. This is automated process. Okay. So this is all about Docker. How we can run our test cases on the Docker container. Okay. So this step is gone. Run tests on Docker with Selenium Grid environment. So try this today's session and tomorrow we'll finish the rest of the things. Guys, everybody's understood today's class, Docker, because you need a lot of practice on this. And this is just for your understanding. Even if you're not practicing this, no problem. Okay, because once you join in the project, so you will learn all those things, the environment, infrastructure, setup, and everything. This is not that much important, but you need to focus more on automation test scripts, how we can write automation test script execution. So that part you need to main focus. If you look at the framework, we have divided into multiple parts, right? So you need to more focus on development part, okay, and execution part. So this part, you need to aware of the process, infrastructure, how we can set up Docker, how we can run on the grid environment. Just aware of that. Even if you're not practicing that, that's not a problem, but you need some information. You have to know exactly what is grid, what is Docker, and how exactly we can execute the test cases on the Docker system and grid. So you need to aware of it. Okay. So I'll stop here. And also I will share this Docker setup document and go through it step by step and execute all the commands and check it. And follow only one, okay? So grid setup with the Docker containers, you can simply avoid just for your understanding and show you. And we need to follow this one. Simple copy this file, install the Docker, copy this file, and execute this command and run your test cases. This is step-by-step process. All right, so I'll stop here for today's session. Rest of the things we'll see. We will move on to the execution part. So far, we have done this part, development, and in the execution part, we are entering. In the execution part, tomorrow I will see how we can execute the whole project through pom.xml, through command prompt. Then how we can install Jenkins, how we can run through Jenkins. And also we will discuss about GitHub in the coming sessions. Okay, that's all. So I'll stop it here for today.